Hi everybody. In this video we're going to take a look at how we multiply matrices together. When we multiply two matrices together, there needs to be a very special condition that has to be met before we can actually multiply them together. So that's in this statement here. Alright, and what it says is that the number of columns of A, if we're doing the multiplication A times B, the number of columns of A must match the number of rows of B. Okay, and that's in the case where we're doing A times B. If you're doing B times A, then you would say that the number of columns of B must match the number of rows of A. Okay, so just in general, the number of columns of the first matrix must match the number of rows of the second matrix in your multiplication. Okay, so that's the condition that needs to be met before we can actually multiply matrices together. If that condition is not met, then you simply say that the product of those two matrices doesn't exist. You just can't multiply them together. All right, and as we'll see in a second, if we can multiply A times B, then it's not necessarily true that that will be equal to B times A. In fact, if you just take any two random matrices and it just so happens that you can do A times B, then it might not even be that B times A exists if you try and multiply them the other way around. It just might not happen. In fact, 99% of the time, that won't be the case. Okay, so just because you can find A times B doesn't mean you'll automatically be able to find B times A, and even if you can, it doesn't mean that they're going to be the same thing. Okay, that's going to be true only if one of your matrices is what we call the identity matrix, which we'll get to later on. So how do we actually do it? What's the procedure? Well, here it is in a sentence. It's a little bit sort of hard to understand what the sentence is talking about, so I'll just jump straight to examples. Let me read it first. So to find entry Cij in the product matrix A times B, what we do is we take row I from A, you take column J from B, you multiply corresponding entries, and then find the sum of the products of those corresponding entries. Okay, so a bit hard to visualize what the hell that means, so let's just jump straight to examples. Here I've got two matrices, A and B, and our job is to find A times B. Let's write down the dimensions of A and B. So matrix A has dimensions 2 rows by 2 columns. Matrix B has dimensions 2 rows by 1 column. And remember, our condition needs to be that the number of columns of A must match the number of rows of B. So this is the number of columns of A, this is the number of rows of B. Those two numbers are equal, therefore we are able to find the product AB. Okay? Now I'm going to show you the way that I sort of learned how to multiply matrices when I first started doing this back when I was in school. I don't do this now because I know the procedure, I'm familiar with it, but you can use it to help you sort of set up your matrix multiplication. Then once you get more confident, you can sort of not do it anymore. But this is what I started doing, or this is how I learned how to multiply the matrices together. So we're doing A times B. So what I'm going to do is write matrix A off to the left here. I'm going to write it 1, 2, 3, 4. And I'm going to write matrix B, the second matrix, sort of above and to the right of matrix A. Okay, so it's -2, -3. All right, and the resulting matrix that we're going to get once we multiply them together, it's going to have the dimensions 2 rows, because there are 2 rows of A, and 1 column, because there is 1 column of B. So we're going to have 2 entries there and there, and they line up with the rows of A and the columns of B. Okay, so the resulting matrix that we get is a 2 by 1 matrix, and you can see that from the dimensions of the original matrices. It's going to be number of rows of A by the number of columns of B. Okay, so that's how you can work out what size your matrix is going to be at the end. All right, now the question is, how do we figure out what goes in each of these entries? Okay, well, I'm going to write the actual answer off to the side here, because we're going to do it in a couple of steps. So first off, we know that we're going to have these entries, but what goes in these entries? So let's look at just the first entry here, row 1, column 1. Okay, so what we're going to do is take row 1 from matrix A and multiply it with column 1 of matrix B. So I'm going to do this row multiplied with this column. Now what does that mean? Well, it means I'm going to take each entry one at a time and multiply them with the other corresponding entry. So what I'm going to do is I'm going to take this number 1 and I'm going to multiply it with negative 2 because they're both the first entry in the corresponding rows and columns. So I'm going to do 1 times negative 2. Then I'm going to add to that the product of the next lot of corresponding entries. So I'm going to do 2 times negative 3. Okay, and that's it. That's it. That's all the entries I have in that row and all the entries I have in that column. Okay, so I'm done figuring out what I need to put in that first row, first column in the product matrix. So now we're going to figure out what goes in this spot here, which is the second row, first column. So I'm going to do these numbers times these numbers. Okay, so I'm going to do 3 times negative 2 first. I'm going to add to this 4 times negative 3. Okay, and that's it. That's the only two entries in our product matrix. And now we can just work it all out. So in the first entry, I'm going to get negative 2 minus 3. So it's going to be negative 5. And in this entry here, I'm going to have negative 6. What's that? Negative 6 minus 12, negative 18, I believe. There we go. Okay, and that's it. Done. Sorry, I've done the first one wrong. That's not negative 5. So we're going to have negative 2 minus 6. That's negative 8. There we go. Okay, there we go. That's the procedure. Okay, it might take a while for you to get used to, but that's how you do it. Okay, to figure out what goes in the first row, first column of your product, you take the first row of A, multiply it with the first column of B. Okay, and you just follow that procedure one entry at a time. Let's do a second example. Okay, so same matrices as previous, but we're going to multiply them the other way around. So here our job is to find B times A. Let me remind you what the dimensions of these two matrices are. Okay, 2 by 2 and 2 by 1, but we're doing B times A. Okay, so let's write down the dimensions of B underneath here. So 2 by 1. The dimensions of A are 2 by 2. And remember, to multiply matrices together, the number of columns of the first matrix, which is this number, has to match the number of rows of the second matrix, which is this number. Okay, what is going on? Here we go. Okay, and you can see those two numbers don't match. Therefore, you can't multiply the matrices together. Okay, you just can't. All right, you just say that does not exist. Okay, BA does not exist. Okay, for the simple fact that the number of columns of B does not match the number of rows of A. Okay, so the order in which you multiply matrices matters. All right, we're able to find A times B, as you can see here, but we can't find B times A because of the size of the corresponding matrices. All right, let's do another example. So here I've got two what we call square matrices, so they're both 2 by 2. All right, and our job here is to find AB. Okay, so we just got to check the number of columns of A matches the number of rows of B. Yep, that's fine. So we can multiply them together. And the size of the product matrix will be the number of rows of A by the number of columns of B, which is going to be 2 by 2. Okay, let's set it up as I did before. So I'm going to write A off to the side here. So it's going to be 1, 2, 3, 4. And I'm going to write B just above to the right up here. So 2, 1, negative 5, negative 2. And you can see that our product matrix is going to have 4 entries. Okay, corresponding to that first row of A, that first column of B, first row of A, second column of B, second row of A, first column of B, and second row of A, second column of B. Okay. Now, to find out what goes in each entry, we simply take each row and column one at a time and multiply the entries in each row and column together, and then add those products. Okay, so first row, first column, first row of A, first column of B, multiply corresponding entries, add them together. So I'm going to do 1 times 2. Oops. Excuse me. 1 times 2. Then we're going to do 2 times minus 5 added to that. So 2 times minus 5. All right, let's do first row, second column. So we're going to do 1 times 1 plus 2 times negative 2. Okay. Second row, first column. So second row, first column. So we're going to do 3 times 2 first plus 4 times negative 5. And finally, second row, second column. We're going to do second row of A, second column of B, 3 times 1 first plus 4 times negative 2. Okay. And then you just put it all together. So 2 minus 10 is negative 8. 1 minus 4 is negative 3. 6 minus 20 is negative 14. And 3 minus 8 is negative 5. There we go. Okay. So there you go. Okay. Try and write this out as you begin. Okay. Set this up, and then you can see what you need to multiply together to obtain each entry. Okay. Once you get confident in how to multiply them together, all you're going to be doing is looking at the matrices as they're given to you, and you'll be able to go from there. Okay. Once you get confident. Okay. But I encourage you to set it up this way to begin with, and then you can sort of line up rows and columns to figure out what goes where. Okay, so one more example. We're going to use the same matrices, but now we're going to do B times A. So we're going to multiply them the other way around. All right, and like I said at the beginning, it's not necessarily going to be the case that A times B will equal B times A. Okay, 99% of the time, that's not going to be the case. Okay, they're going to be different. Let's see what we get. So here I'm going to write B first on the left. So this is going to be B. So 2, 1, negative 5, negative 2, and up here to the right I'm going to write matrix A, which is 1, 2, 3, 4, and you can see our product is going to be a 2 by 2 matrix because there's 2 rows of B and 2 columns of A. 1, 2, 3, 4. Alright, let's go through our procedure. So let's do first row, first column. So first row, first column, I'm going to do 2 times 1 plus 1 times 3. Let's do second row, first column, so negative 5 times 1 plus negative 2 times 3. Let's do first row, second column, so 2 times 2 plus 1 times 4. And second row, second column, we'll do negative 5 times 2 plus negative 2 times 4. There we go, that's our procedure done, and now we just got to clean things up, write the final answer. So here we're going to have 2 plus 3, which is 5. Here we're going to have 4 plus 4, which is 8. Here we're going to have negative 5 minus 6, which is negative 11. And here we've got negative 10 minus 8, which is negative 18. There we go, okay? And you can see, comparing that to our previous slide, A times B is completely different to B times A, okay? So even if you can work them both out, most of the time they're not going to be equal to each other. They'll be completely different. All right, that's it for this video. Go through it again, make sure you understand the procedure, and get plenty of practice multiplying your matrices. I'll see you next time.